Hello everyone, welcome back to Lyfey Technologies YouTube channel, and thank you so much for watching and supporting our channel. So just a kind reminder that if you are watching this video and you are yet to subscribe to our channel, kindly hit that subscribe button to support our channel and also to stay tuned for more upcoming videos. So this is another episode of our Nokia Lab Simulation series, and in this episode we'll be discussing how to configure VPRNs on Nokia routing devices. So we know that we have the virtual routing and forwarding, that is for Cisco, and then Huawei we normally call it VPN instances. On Nokia the VRFs are called the VPRNs. So these are L3VPNs, layer 3 VPNs that can help us to segment services into different instances. So in this lab simulation, we'll be demonstrating how to configure VPRNs on Nokia, and you can see that in this topology, we have the PE router. So the router in the middle will be our PE router, and then we have 4 customers. So we have 2 customers in one VRF, so C1 and C3 will be in one VRF, and then C2 and C4 will be in the same VRF. So we need to ensure that we have communication between same VRFs, and will not have communication between routers in different VRFs. So this is just a simple implementation to demonstrate how you configure VPRNs or VPN instances on Nokia, and then we will go ahead and now implement the BGP MPLS IP VPN when we have routers connected to different PEs. So we can have customers, like you can have C3 and C4 connecting to a different PE router. So that is what we'll be doing next, but in this setup we'll just do simple simulations of how you can configure the VPRNs. So you know that when we talk of VPRNs, there are 2 things that we normally focus on. We have the route distinguisher and the route targets. So the route distinguisher are aimed to make the routes unique, while the route targets or the VRF targets are used to control the route import between different VRFs. For the PEs in different VRF, they will have to exchange the routes based on the VRF targets. So for the implementation, we'll be doing basic configuration. We need to configure the interface IPs, and remember these interfaces will all be configured under the VRFs. So we need to configure the VPRN. Once you've configured the VPRN, we'll configure the interfaces within the VPRNs, and then we can go ahead and configure the CE devices. We'll be using static routes because this is just a simple implementation of how you configure VPRNs on Nokia routing devices. So to start us with, we have the connections. We'll start by checking the connection. So on this router, if you run show system LLDP neighbor, you can see that we have 4 connections to R3, to R4, to R5, and to R2. So you expect to have a similar connections show system LLDP neighbor. You can see that we have 1 connection on R2. On R3 show system LLDP neighbor, you also have 1 connection to R1. R4 show system LLDP neighbor, 1 connection on C3, and finally on R5 show system LLDP neighbor, you have 1 connection to C4 on R1. So once you've verified that we have the connection and the physical connection are up, we can now go ahead and start configuring our interfaces. So the way we do it on Nokia, the first thing that we need to do is to create a service. So we'll be configuring all the VPRN parameters under the service. So if I were to exit and then configure service, you can see that we have customer 1 created, so we don't need to create another customer. We'll just be using this customer for our implementation. So to start us with, we need to configure the VPRN. So the command is, you have to start with configure service VPRN, then you can use the question marks. So VPRN, we give it VPRN ID. So we'll give it VPRN ID of 100. You can give it a name. So you give it a name of VPN1, and then it's customer 1, then create. So this is the command that we need to run. Once we've run this command, we can now go ahead and configure the route distinguisher and the route targets. So for the route distinguisher, you just need to run the command route distinguisher. We'll be using 100 and then :1. and we need to configure the VRF target. So for VRF target, it takes a different format. You have to write target and then you append the VRF target. So we'll be using 100:2. So if you do info, these are the configurations. You can see that we have under the MPLS, we have the route distinguisher and we have the VRF target. 100:2, this is the route distinguisher. So I can do no shutdown info. So these are the configurations that we need for us to be able to create VPRN 100. We can go ahead and create the other VPRN also. So it's configure service VPRN 200. Its name, you give it name VPN2. Once you have given it VPN2, it's customer 1, then create. Then we can configure the route target. So the route distinguisher and the route target. Route distinguisher will be 200:1, and then VRF target will be target 200:2. I'm missing a colon here. That is the format. Info, no shutdown. So when we do info, you can see that we have the VRF, configure service, info. So you can see that we have one VRF 100. These are the parameters configured, the route distinguisher and the route target. And then we have VPRN 200. These are the route configured. These are the route distinguisher and the route target. So once we have done this, the next step will now to configure the interfaces under these VRFs. From the topology, you can see that we have to C1, Ethernet 1 will be connecting to C1. So we need to configure an interface facing to C1, and that interface will be configured under the VRF. So I'll do VPRN 100. If you do info, you have the VPN parameters, and then we configure interface to C1. Create info, so you have the interface information. The first thing that we need to do is to configure address. So it's address, we can verify the IP address assigned 2020.26. So we have an address of 20.20.20.6, mask is 31. And then you need to show system LLDP neighbor. You need to configure the port. So the port connecting to R2 is C1. So this is the port that we need. Let's see if it will accept, or we need to change the mode. Now we need SAP. This one should be the SAP. Create. You can see that it's telling us that it's not an access port, so we need to change the mode to an access port as usual. So for us to do this, we'll configure port. When you have the /, you can always run the commands. This port, we first need to shut down the port. Once we've shut down the port, we can now go ahead and Ethernet mode access. So we have an access port. We can continue with our configurations. So we have interface to C1, info. We need to configure the SAP. Create. So we have the configuration. So this is how you create a service on Nokia. If I do info, you can see that we have the address, we have the SAP, and then we need to unshut the command. Remember, we had shut down the command. So I will do no shutdown. Exit info, you have your interface configuration. So interface to C1, create, you have assigned IP address, you've created the SAP pointing to the customer. So once you've done this, we can create the other interface. So the other interface in VRF1, it's to C3. The IP address will be 20.20.20.2. So I'll configure interface to C3 to C03. We need to add the create command. Address is 20.20.20.2, mask is 31. Then we need the port, but before we configure the port, we need to change the port, shut down, and then this one should be 2, not 1. Now shut down, we need C2. C2 shut down, and then C2 Ethernet mode access, and then we need to enable the port. So if you check info, you have the configuration. We need to give the port, not the port but the service access point. Create info exit info. So you can see that in this setup we have two interfaces. We have interface to C1 and interface to C3. So those are the two interfaces that we need to configure for VPN1. So I will configure VPRN 200. For VPRN 200, we still have two interfaces. We have interface to CE2 and interface to CE4. Interface to CE2, it's 2024, and then the other one is 2020. So we'll start by configuring the port. Let me start by configuring the port. So configure port. We have port C3. We'll shut down. And then we need to Ethernet mode access. Let me also do the same for C4. So that I don't have to reconfigure it. So it will be now shut down. Then C4 now shut down. So if I run show port, the ports are up. So we are in VPRN2. So for VPRN2, we need to create interface to CE2, to CE02, create address. We check the address again. This is 20.20.20.4, 20.20.20.4, mask is 31. And then we need to bind the sub. So the sub will be C3. Then create info exit info. We have our first interface configured. We'll create the interface to another interface to C4. So interface to C4, create address 20.20.20.0, mask is 31. Then we need to bind the port, not the port but the service access point. This will be C4. We need to add the create command info. So these are the configuration. We have interface to C2, interface to CE4. We have configured the correct IP addresses, and we have configured the route distinguisher and the route target. So the next step is to now configure the CE. So we'll be starting by configuring C1. So configure system name CE01, and then we need to configure the router. So it's configure router interface to P1, and we give it address of let's check the IP address details. This is 20.20.20.7, mask is 31, and we need to bind the port. So the port should be C1 on the routers. Info exit. So configure router info, you have the interface configuration details. We can also configure system interface, so interface system that we'll be using to test. Address will be 3.3.3, mask is 32. Info, you have your configuration, your interface configurations. So we'll go ahead and configure C2 for R3. Configure router interface system address should be 4.4.4, mask is 32. Then configure router interface to P1. P01 address will be 20.20.20.5, mask is 31. Info, then we need to bind the port, so the port will be C1. Info, exit, and then we can do the configurations for sorry for this, I need to make it clear. So on R3 it's connecting to show system LLDP neighbor. You can see that it's connecting on C2. It means I've done something wrong, or no, C1, C2, C3. Okay, C3. So for R3 we'll be connecting to C2. Let's check. So it's configure router interface system address. We check the address, it's 4.4.4, mask is 32, and then configure router interface to P1. Address will be 20.20.20.3, mask is 31, and then port will be to C1. So this is the port. Info, you have your interface configuration, show router interface, and then we can go ahead and configure. This is R3. And then which one have we not configured? R4, 5.5, show system LLDP neighbor. This is connecting on C3. On C3, let me verify the connections again. Show system LLDP neighbor. You have R4 connecting to C3. Then we have R5 connecting to the best way to verify is to configure the system. Configure system name. This one will be C03. Then on this router, configure system name C04. So once we've done the configuration on C3, this is C3, show router interface. Configure router interface system address will be 4.4.4, mask is 32. We'll verify the configurations on P1 once we are done with the configuring the CEs. Configure router interface to P01. Address will be 20.20.20.3. Mask is 31, and then port is still connected to C1. Show router interface. So that is okay, and then we need to check on R5. So R5 is C4. Configure router interface system. The address will be 5.5.5. I see where I made a mistake on the router ID. This is R4 will be 5.5.5, mask is 32. And then configure router interface to PE01. Address should be 20.20.20.1, mask is 31. Info, and then port, the port should be C1. Invalid port, wrong port. Info, show router interface. You have the two interfaces, so let's verify on R1 how the connection are. Show system LLDP neighbor. You have, where is R3, we'll name it to. So on R1 you have C1, C3, C4. So R3 should be our system name, C02. Show router interface. So we have configured .3. This is wrong. We need to configure router. Let's verify. Show system LLDP neighbor. It's connected on C2. This is for C2, is connected to C2. So on R1, this is the port. This is the port connecting to C2. If I run info, you can verify that we are in VPRN 2. So exit info. So I'm just verifying the configuration to verify that we have configured the addresses in the right VPRN. So you can see that VPRN1 has to C1 has address of .6, which is okay, and then interface to C3 has IP address of .2, which is okay, and then we can check the other ones. So VPRN 200 to C2 has .4, and then to C4 has .0. So one thing that we need to do is to verify the CE configurations. You can see that interface to C1 is set to .6. Where is C1? So this is .7, that is okay. And then interface to C3 is set to .2. Show router interface. We are good. This one is set to .3. And then R4, show router interface. This is also set to .4. This is wrong. Address should be 20.20.20.5. Mask is 31. Then finally on R5, show router interface. You have .1, that is okay. Another thing that I need to check on R2 is the router ID. So on R2, interface system should be configured with C1 it's .3, C2 is set to .4, C3 is also set to .4. So I will change this one to be C2. Configure router interface system address 2.2.2, mask is 32. So show router interface. Once we have done this, we can now go ahead and verify. For example, if you want to check the interfaces in a VPRN, you show router VPRN. show router the VPRN ID. So the VPRN ID will be 100, and then you can either say, for example, interface. You see that we have the two interfaces in VPRN 200, 100, and then VPRN 200. You also expect to have the two interfaces. So this is how you check. If you want to ping through a VPRN, or if I want to show router 1000 route table, you can see that we have the local routes. I can check for 200. You have these routes. So are we able to ping? We can try to ping router. You have to specify the VPRN ID 100. 100 we have 20.20.20.7. You can see that we are able to ping. Then the other side we have .3, so we are able to ping. But if we try to ping from PE to C using the VPRN 100, let's try. This one was .5. You can see that we are not able to ping from one VPRN to the other. So if you want to ping, then you need to do some route leaking. And remember, in our previous episode, we have demonstrated how to do route leaking on Huawei routing devices. We will also demonstrate how to do route leaking on Nokia in our upcoming episodes. So we can also ping router VPRN 200, and then we specify the IP that we want to ping. So 20.20.20.5. You can see that in this VRF we are able to ping .1. We are able to ping. So if I run show router 100 ARP, this is how you check the ARP of a VPN instance. You can see that we have the MAC addresses. If you do 200, you can see that we also have the MAC addresses learned from this router. So the configuration, again, very simple. You need to first create the customer. Once you've created the customer, you can now go ahead and define your VPN instances, and you use the VPRN and then the VPRN ID. You can give it a name. In this instance, we gave it VPN1, and then you can now create the interfaces that you want to configure within this VPRN. Once you've finished configuring the interface, you need also to configure the route target and the route distinguishers. So the route distinguisher is configured in this format. Many times we use the AS number colon a random number based on the requirements, and then the VRF target, you always have to start with the target and then the S number colon a random number. So when you are doing the implementation, of course, you have to do a proper planning for the route distinguisher and the route targets. And once you've done that, show router 100 route table, or even show router 100 interface. It will tell you that I have these interfaces in this VRF, and then 200. It also tells you that I have these routes in this VRF. So this one is very easy to configure. Again, these are the configuration. Specify your VPRN ID and you give it a name, is the best practice, and then you need to refer to the customer. And once you've done that, the route distinguisher and the route targets. So I hope you've enjoyed this session, and if you have, just leave a comment in our comment section, like the video, and also if you are watching and you are yet to subscribe, kindly subscribe to our channel to support it, and also to stay tuned for more upcoming videos on Nokia Lab Simulations, on Huawei Simulations, and even on IPRAN, and many other content that we'll be covering in our upcoming videos. So thank you for watching again, and just hit that subscribe button. Thank you.